So hi everyone, I hope you're having a good day, although it's a bit grey outside. I've just come straight from a wedding in Scotland, not mine, so hence the attire. I'm also a bit trashed, but we'll get through it, it'll be fine. So don't let the fact that I'm a qualified engineer put you off. I am actually a hardware hacker as well. So you can't hear me. Can we increase the... See if that's better. Is that any better at all? I'll have to try and speak out the corner of my mouth down into the lapel mic. That might work. Am I audible? Ish. Okay. You could even move forwards. Okay, so if let me know if this is bad, and I'll just switch back to this mic here. So basically, what we're going to talk about is how you can make metal castings without spending tens of thousands of pounds and having a huge factory and so on. So basically, I've just got a rep-wrap style 3D printer that you can put together from a kit or buy for about £300 to £1,000, and if you've got access to a few other pieces, you can make metal castings from that. So I'm just going to show you basically how you do that. So the pic I hope you can see here, or on the plasma screens up there, basically on the left hand side is a CAD model of a thing, and on the right hand side is the resulting metal casting that was I created. So I'll run through how you go from the picture on the left to the picture on the right. So the purpose of the talk is, you can see me holding a piece of plastic there in my left hand. I want to show you how you can turn that into the piece of metal. So the piece of metal you can see in my other hand, it's got some extra bits attached to feed the metal into the part, so those get chopped off, but basically it's how we can turn a 3D printed part into a metal casting. These days things are very advanced, and in fact you can 3D print with a laser. You can direct print parts in metal anyway, so you can nowadays completely skip out casting things. You can just go from a CAD model to a laser sintered metal part in one step. So you can make turbine blades, which in a very short period of time will render more or less the entire casting industry completely defunct, but that's another talk. However, there's a small problem with that, is that to do that you need a machine like this, which costs about £500,000. So we've got a small step to jump before you can really start having metal parts from a 3D printer. You can, but only if you're rich. So for the time being, it'd be nice if there was a way of making metal things without having £500,000. So what we're going to talk about now is a quick overview of casting process. What is it? The equipment required, so what bits do you need to buy? Making the pattern, assembling it, pouring the mould, pouring the metal in, getting your casting out, some general rules for how to make castings that aren't full of holes and fall to bits. And if I've got time, we'll look a little bit about some simulation things you can do with open source software, and hopefully some questions at the end as well. So how do we cast things from metal? So there's loads of different ways of doing this. This is only one. So this is the oldest way to do it, which was probably invented in Iraq about 6,000 years ago, roughly. So what they would do was they would carve a pattern of the part they wanted out of beeswax, and they'd basically get some clay from the riverbank and splat the clay all over around the outside of the beeswax mould, which takes you up to number 3 there. Then basically what they do is they'd fire it. So you put your carved wax piece covered in clay in a kiln, and that takes you up to number 5. So you completely vaporize all the beeswax, and you basically have a clay hollow, the inside of which is the shape of the piece you would like to have in metal. So then what we do is basically we heat some metal up, We pour it into this hollow flask, you let it cool, and then basically you hit it with a hammer, and the whatever you're using, the clay or the ceramic, basically shatters and falls off. Then you chop off the bit at the top where you've poured all the metal in, and in this case you've got a very exciting apple, tennis ball, golf ball, whatever you like, but that could be any shape you want. So basically we can do exactly the same thing now, but we don't have to hand carve a wax pattern. If you've got a 3D printer using PLA, for example, that's polylactic acid, so that's the cheapest printing filament you can get. You can 3D print the shape you want, which means you can make a very funky shape. You don't have to sit there for weeks carving it. And if you want 10, you can just print 10 and they'll all be the same. You don't need to pay a little man in the shed to sit there for a month carving up little blocks of wax. So I used a variant of this, which is called block molding, it's basically the same thing, but basically you put a tin around it and you just pour in a whole load of basically plaster, is essentially what it is. And this plaster piece sets, and then you put it in the oven, and I'll run through all this with you. So basically what I'm pouring in here, if I assume that I want to have the white coloured piece, which is basically the tennis ball, you've got to have a funnel on top, so you need to have some way for the metal to go into the thing you want to have. And basically you need a tin, could be anything, and essentially what I'm going to pour in there is basically plaster of Paris with a few extra little bits. So it costs, the materials are basically zero cost, you can get them anywhere. So the really important bit is, what do I need to buy? Because if you can't buy any of this stuff, you can't do it. So I've got an Ultimaker 3D printer, but you can use any 3D printer that makes parts from PLA plastic. If you've got one of those, or you know a friend who has one, or you know a friend's friend who has one, you can make patterns to make castings with. That's all you need. The expensive, difficult bit, there's two ways to do it. There's a proper way to do it, which will cost quite a lot of money, or you can do a proper hacker style way, which costs a little bit less, but it's going to require a bit more experimentation. So basically what you need a way of burning out the plastic from the inside of the pattern, and you need a way of melting metal to pour it in. So if you haven't got that, you can't do it. So the cheap, easy way to do that is just to get a propane furnace, like the one you can see in the picture up here. And basically that will work, but it's quite tricky because you can't regulate the temperature very easily. So it's a bit kind of, it's not very repeatable. It's quite tricky. If you're very lucky like I was and you're at university at the time, you've got access to a temperature controlled oven, that makes life a lot easier, but you don't need to have that. So if you've got maybe a sort of a garage and a little bit of space out the back, you can buy a propane burner, which I think you can put together the whole lot from eBay for a few €100, and that will work. People do that. A useful thing to buy is a thermocouple reader, because you do need to know how hot the metal is. Contrary to numerous YouTube videos, liquid is not the correct temperature. You need to know what the temperature is. So if you don't have a way of measuring the temperature, it will not work. And it's not the most expensive piece, so buy a thermocouple reader. The small stuff you need is, first of all, some not going on fire clothes. I recommend these. They're not that useful. What I really recommend you do is you buy some house bricks and you stand on the house bricks when you're casting. The trouble with the leather overalls is that whoever invented them didn't watch anyone doing casting, because if you spill the metal on the floor, you actually dissolve from the bottom up. So if you've got a leather apron on top of you, this will not assist you. So buy some leather overalls, but also stand on some bricks when you're doing this, because if you pour a litre of aluminium at 700 degrees on the floor, you don't want to be on the floor, so stand on bricks. The second thing you'll need is just plaster. This is basically plaster of Paris. The third thing you need is basically sand, and then you need some glass fibres. And you put all these together with water, and this basically makes a ceramic slurry, and this is what you're going to put around your 3D printed plastic mould. And you also need some aluminium. I recommend you buy some aluminium from a distributor of casting aluminium. I don't recommend you melt down Coke cans. You can do that, but it will not be a functional part. It'll be a doorstop. Basically, a can is a very, very thin thing, so it has a very large surface area and almost no metal in it. So basically, what you're melting is about 50% oxide, and you don't want oxide. So if you use aluminium cans, you're going to end up with mostly oxide with a little bit of metal added, which is the wrong way around. So it's best to buy aluminium blocks from someone who sells casting aluminium. But if you just want something that looks nice, it doesn't matter. But if you try and pull on it and you don't want it to snap, don't use Coke cans. So basically, the three ingredients for the mould I was talking about are plaster of Paris, which is number one, sandblasting grit, which is the second one, and some glass fibres. So basically, if you don't put the sand stops the plaster from shattering at the high temperature, and the glass fibres mean that basically, if you do get a little hairline crack, it doesn't open, so the mould will stay in one piece. So if you're making quite a big mould, you need to have some of that in it. So all of these things cost £20 for a 30 kilo bag or something. It's not expensive. This can be a bit tricky for a lot of people because unfortunately in the open source software scene, CAD is one aspect in which it's sorely lacking, which is basically drawing things on the computer. Unfortunately, there are not really any very good open source free CAD packages yet. There are some that you can use. So basically, if you can use Google SketchUp, you could just draw something you want, and then you could use that to make the 3D print, and then you can make a casting from it. But you're a bit limited with the geometry you can use there. But if you have a CAD model, you can make the casting. So I went over a little bit this earlier on, but I'm going to go through it again. So I got my dates wrong there, 5,000 years ago, not 6,000. But this is basically a real example of a 5,000-year-old casting, which is beeswax. So we're just using 3D printed plastic instead of beeswax. But if we did want to make an apple, excuse the date, I gave this talk in Germany last year, so it's still got some references there. So basically, you'd find a CAD model or draw a CAD model of your apple, create the 3D printing code to print it, 3D print your apple, this is my 3D printed apple, and then we can cast it. So what I'll talk about a little bit is how to design your mold, because you need a way of putting the liquid metal into the casting. And what most people do is just put like a kind of funnel on top of it and pour it all in, which is basically the worst possible way you can make a metal casting. And don't ever do that. So basically, the metal should always go in from the bottom up. So you should never, ever, ever pour it down from the top. So this is essentially a kind of baseline you could follow to design your mold. The reason we do it like this is if you pour it in the top, basically the metal splats and kind of falls down and bounces off other bits. And if you've ever made hot chocolate, you know, if you let it sit there for a minute, you'll get this horrible skin on the top and you have to throw it off. Basically, when aluminium is liquid, it's forming a skin on it. And every time a bit of it is exposed to the atmosphere, it forms a skin, which is basically a skin of a bit of rubbish it's not metal, it's oxide. So every time it splashes, basically lots of little bobbles are getting covered in air and they're forming a skin on. So basically if you pour your metal in just straight from the top, you're guaranteed to have complete rubbish parts that are full of bits of air and oxide and all sorts of stuff. So basically you want to pour it into the dark blue bit, it flows down the green bit into the bottom. So the thing I want from the casting, that's the bit I want. So I'm going to pour the metal in here, it's going to flow down here and rise up like that. So that's kind of the rough shape you want to kind of try and have. So I've 3D printed all these parts on my 3D printer at home and glued them together with super glue, which is that there. So that's all these parts just super glued together basically, and put into a box. I've tried to be quite clever with this box, but you don't need to do that. You could literally just use a biscuit tin. Okay, it doesn't matter. It's just something that you can pour your plaster into. It doesn't leak out the bottom. That's all you need. So this is my pouring bowl. I'm going to pour the liquid metal in here, down here, and that's going to fill up like that. So in this case, this is my finished box. As I say, you don't need a clever box like this. You can just use any kind of tin, doesn't matter. So I've now mixed up the plaster mix, which is just the plaster of Paris with some sand, some glass fibre and some water. Mix it up until it's quite thick, pour it in, and then you leave it for about an hour, and then it's set. So then what you have is a set block of plaster of Paris with inside it's got your plastic 3D printed part stuck in the middle of it. That's what you've got at that point. So what I do now is I leave that for an hour until it's set, and then I put that in an oven, or if you've got your propane burner or whatever, you can just put it inside that for a few hours, and basically the 3D printed plastic will completely vaporize. So I heated it to 600, but anything above about 450 degrees will completely vaporize the plastic. And PLA is basically made from cornstarch, so it doesn't give off very, very toxic fumes. It basically just decomposes into carbon dioxide and a little bit of carbon monoxide. I don't recommend you use other plastics for this. Like, I do not recommend that you use nylon, for example, or ABS. Because when they decompose by burning, they give off very, very noxious stuff. It's really, really bad for you. So I recommend just using PLA. It's pretty safe. So basically what I've got here is, this is the block after the plastic's been burnt out. So I've got a block of plaster of Paris, and all these holes are where the plastic was. So now it's just an empty shape inside my block of plaster. And if you're lucky enough to have an oven with some temperature control, this is the kind of cycle you can use when you're burning out the plastic. You don't have to do this. As I say, people do it in the back garden with a propane burner, and they just stuff the block in there and leave it for a few hours, and the plastic burns out. It's fine. So now we've got to melt the metal. This is also an outdated slide. I had quite long hair back then, but long hair is not a very good thing to have when you're making castings and so on, and it's quite warm. Don't recommend it. You'll read lots of stuff about how you prepare the metal. The best thing to do is don't put any kind of treatment stuff in it. Just melt it and leave it being melted for about 45 minutes. And basically what happens is all the rubbish kind of just floats very slowly up to the top. So do not stir it. That's the worst possible thing you can do. You just leave it until it's stuff flooded up the top. Scoop off the bit of the top, and then you're good to go. Don't stir it. That's the worst thing you can do. Now, if you've listened to the first part of the presentation, you've bought yourself a thermocouple reader with a thermocouple. So you stuff that in and you check how hot the metal is. If it's the wrong temperature, it won't cast very well. So basically, you should heat it to about 720 degrees. If you heat it much hotter than that, it'll take a really long time to cool down, and you'll end up with a rubbish casting because it'll be oxidizing all the time it's hot. And if it's not hot enough, it'll solidify while it's pouring in. So you'll get your casting and find you've only got about half of it because the metal's gone solid before it's flowed in. So that's why you want to check how hot it is. So I'll show you now a quick video. Hope this works. Really? Seriously? Help? Yeah, I desperately need assistance here. It's all gone wrong. Yeah. Very good. You don't really need to find a Sicilian friend, it's okay, but I had one, so it was good. So you don't have to do this, but we're trying to be very clever here because we were at university and you're supposed to be clever there apparently. So you've got like a stopper, which is basically just like a clever kind of way of having the plug in a bathtub. So you fill it up and then you pull the stopper out, but you don't have to do that. So this is the metal now in the crucible that I've checked is about 720 degrees. There's quite a lot of metal in here, so it's advisable to not drop it. So I'm going to fill up the pouring bowl, and then when it's ready, my friend's going to yank the plug out. And if you look at the back, you'll see the metal flowing up at the back in a minute. So then the metal's completely flowed into the mould. So what you should always do is have a little tin to pour in the residue, because it's very bad to leave the metal in your crucible to solidify. The crucible is a very sort of fragile thing, and it's very bad for it to leave the metal in there. So I have a quite expensive oven here, but you don't need to have this. You can do it with a propane burner if you have that still works. So basically, after you've smashed all the plaster off, you end up with that. And now it's probably going to play again. That's okay, because I'll continue talking because I had a few other things to say. Basically, what we do is you leave it for about 45 minutes, and then the metal solidifies enough that you can kind of work with it. And then basically what I do is I get it with some tongs and I drop it in a bucket of water. And basically the shock kind of blows all the plaster off. So you end up then with just the metal part. And then basically you just hacksaw off the bits you don't want, and you've got your metal casting. So there's loads of different ways of making metal castings. This is just one. If anyone here knows about castings, you can also use the 3D printed parts to make sand castings, but that's a bit different technique. But this is just one way you can do it with pretty simple, cheap materials, and especially in the hacker scene, I think a lot of people know someone who's got a garage workshop, or maybe someone who works at an art college. If you know anyone who works at art college, they've got access to ovens and stuff where you can do all this kind of thing. So normally, somebody will know someone with the facility to do this, but if you've got a 3D printer, the point is you can make all the patterns yourself in your room, and you can just go there to do the expensive bit, which is with the oven. So obviously I've skipped over a huge amount of stuff here because it took me about 2 years to figure out how to do this, and I'm trying to explain it in sort of half an hour. But the point is that this will be uploaded, and you have my email address, so if you have any questions at all, you can just say, hey, what's that detail, and I'll fill you in. So basically that's the part after the metal's solidified. So basically now we just dunk that in the bucket of water, the plaster will come off, and you can just pretty much brush it off, and that's it done. So that's what it looks like when you're the plaster just kind of comes off at that point. It's really easy to take off, and that's the finished casting. So it looks like a glorious success there, but I messed up like 20 to get to that point. But now I know how to do it, it's okay, but it was a long time getting to that point. General rules for success: if you do find someone with some equipment, or you want to buy some and you start messing around with it, 90% of castings go wrong because the metal is turbulent when it flows into the mold and it gets oxidized. So what you're always trying to do is get it to flow in without splashing. That's basically the main reason why they screw up. So do not splash the metal, do not stir the metal, Do not pour some of it on the floor and then kind of scoop it back in. Don't use Coke cans. Some of the other stuff I've already run through briefly, but buy a thermocouple reader, check the metals at the right temperature. There is a good reason for doing this. If it's molten, that's not the correct temperature. It might work, but if it does, it'll be by pure luck. If you're fine with that, that's all right. But as I say, you can get lots of kind of treatment stuff for the metal when you're melting it. You can get all these clever stuff that's supposed to like remove the impurities from it. And it's all basically a waste of time unless you've got a whole factory set up with all the processes controlled. The best thing to do is melt it and have it still molten for like 3/4 of an hour and just leave it for the rubbish to float up. Skim the surface off, and that's the best thing you can do with it. If you want castings which are mechanically useful, so you might do something structural with them, what you would always do is you would only ever use fresh casting ingot. So you'd buy some aluminium from like someone who sells casting aluminium, and you'd buy it fresh, and you'd throw away all the old stuff. You don't put it back in the pot afterwards. You don't have to do that, but if you want things that are mechanically strong, the best foundries do not reuse any of the metal at all. It's all recycled after it's used once. But if you're messing around, that's a bit extreme, but that's what you aim for. Something quite dangerous, the plaster moulds. The mould is basically plaster and water. So if you do not dry it properly, you're going to pour metal at 700 degrees into something with water in it. And what happens then is that water becomes steam in a fraction of a second. And if you're kind of leaning over it like that, what happens is you'll get like a sort of free steam bath in the face. So it's very important when you make the mould to dry the block of plaster with in your propane furnace or whatever for like a long period of time. It has to be completely bone dry. So I'd recommend 24 hours if it's like a big block like that. If you're just doing some little stuff, like if you're making some jewelry and you've just got a little block like this, like a couple of hours, but for a big block, it needs to be a long time. If you're into software stuff, you can use open source software, which I use a lot, called OpenFoam, and you can, if you're an engineering geek like me, it's very exciting to simulate the metal flowing in and make some nice stuff like this, but you don't need to do that at all. It's just kind of fun if you're a techie like me and you like looking at the problem from lots of different perspectives. So I've got a website, and I've put most of the information you've just seen on my website, so you can see most of the information there. Ultimaker, that's the 3D printer I've got. The Complete Casting Handbook, that's the only casting book I've read that's actually any good. Kiss Slicer, that is a free software to make the code for the 3D printer, to turn your CAD file into a G code for the 3D printer. It's the best one, I think. And that's about it. So I've obviously had to rush a lot, but I thought it's best just to give a sort of an overview, and then if you have detailed questions, you can give them now, or you can look at the website, or you can come speak to me afterwards, follow me home, whatever works for you. So I hope that was instructive, and I hope someone's got some questions, because if you don't, you weren't paying attention. Can we have someone with a mic? Okay. Ask me the question and I'll repeat the question so other people know what you said.
Can you tell us about some of the times when it went wrong?
Oh, yes. So, for example, I poured the metal into the mould and I let it cool for only 10 minutes instead of 45 minutes. And then I put it in the bucket of water, and the metal was still molten in the bottom, and it basically completely exploded everywhere. So that was quite cool. Other stuff, when you're making the plaster, you have to make it quite thin or it doesn't flow into all the little, if you've got a really complicated shape with lots of little holes and passages and stuff, you have to make the plaster very, very thin or it won't flow in. So if you've got a really complex shape and you make the plaster quite thick and you pour it in, you don't really notice, and you'll make the casting and you'll just find you've just got like a blob because it didn't flow into the cracks. In industry, they get around this by putting the whole thing in a vacuum chamber after they've poured the plaster in. But that's starting to get out of the realms of kind of do it in the garage. So the best thing is just to make it quite thin. So if it's thick, that stuff can happen, then the casting doesn't work. Yeah. 2 examples. I have many. But it's very fun to mess with, which is the point isn't always to make the thing that's perfect. It's fun to mess with it. Hi.
On one of your slides it said do the correct pouring temperature, and
Yeah.
it said the mold at 300. Does that mean you have to preheat the mold?
This is strongly dependent on how thin the thinnest piece of your part is. So if you've got like if you want to cast an apple, which is a blob, you can do it at room temperature because there's nothing thin there. You can just pour the metal straight in. But if you're casting like something like, I don't know, a butterfly or something, which people do, amazingly enough, you'd have to have the mold hot, or the metal will chill before it flows into the thin bits.
Do you have to take account of the expansion when you make the 3D print in the first place? Do you have to maybe make it 1.3 times?
Oh, that's a very good question. So I'm sorry, I forgot to repeat the initial questions, but yeah, I'll repeat this one. Basically, the question is, how big do I make the 3D printed part? Because it all shrinks. This is a really, really good question. So basically, on my 3D printer, when you print the plastic, it shrinks 0.5%. And then when you pour the metal in the mold, the metal shrinks when it cools. So what I do is I make my CAD model 1.75% bigger than the part I want to have in metal. And that ends up, for aluminium, that'll get you pretty much there. For other stuff, I can't tell you because I haven't tried it.
Does the metal flow naturally to each high point in the design, or do you have to make vents so it doesn't get airlocked?
So the problem with the plaster method is the mold's not very porous. So you have to have a vent at a high point, or it won't flow up into it. But a lot of people just put a lot of people would just get like a bit of welding rod and just sort of stuff it in. So you only need like a tiny little hole, but yes, you have to have that.
What's the part that you're casting?
Oh, that's a good question. The part I'm casting is it's a friend of mine races very old motorcycles, and they're always breaking, and there are no new parts. And the original parts aren't very good. So, because, well, firstly, they're old motorcycle parts, which are terrible all over the world. And no insult to any Italians here, but they're old Italian motorcycle parts, which means they're even worse. So it was a little side cover for the side of his engine where the kickstart comes out. So, yeah, it works. But that was a lot of experimentation to make one part, but yeah.
If you have to make a very small fine part, are there any other considerations that you do before you start some things such as
Can-
the consistency of the plaster?
I'm sorry, can you repeat that, please?
Making a very small one,
Yeah.
do you change the materials that you put into the plaster, or are there any other considerations?
There's a sort of general rule, which is that if you want to cast something under 3 millimeters thick, basically you can't do it without a vacuum. So you can't sort of scale parts down. You can't sort of go, oh, I'm going to make one 10 times smaller and scale it 10 times smaller, because if you go under 3 millimeters, the metal probably won't flow through it. So as long as you observe that general rule, you can make stuff as small as you want. If that's it, then I'll wrap up. Oh.